Hello everyone, welcome to this series of mathematics lessons. In this presentation, we will study about lines and angles. Lines and angles. Identify whether the angles made are acute, obtuse or right angled. When we consider these two angles, angle between these two lines is more than 90 degree. So this is an example of obtuse angle. When we consider these two lines, the angle between these two lines are 90 degree. So these two lines are right angled. When we consider these two lines, the angle between them is less than 90 degree. So this is acute angle. Line segment has two endpoints. Here we can see the line segment PQ has two endpoints, P and Q. If we extend the two endpoints in either directions endlessly or infinitely, we get a line. Here we can see in this example, this line is extending forever in both the directions. A ray has only one endpoint. That is also called as starting point. Here we can see this is an example of ray OP. It has got one starting point and other end has no end for it. So this is an example of ray. Generally, a line segment is denoted by placing a small line over the symbol, and a line is represented as it is. Here we can see in example 2, AB is represented as AB. The line AB is represented as AB, and the ray OP is represented by placing a small line over the symbol. Angle is formed when lines or line segments meet. In the diagram 5.31, we can notice that line segments AB and BC intersect at B form an angle ABC. And again line segments BC and AC intersect at C, forming an angle ACB. Here we can see in the second example, two lines are intersecting at one point, which forms four angles: angle POS, angle POR, angle ROQ, and angle QOS. Related angles, complementary angles. When the sum of the measures of two angles is 90 degree, the angles are called complementary angles. In the diagram 5.4, we can see the angle between these two lines are 30 degree. This is one part. In the second part, we can see, in the second subpart, we can see the angle between these two lines are 60 degree. When we add these two, 30 degree plus 60 degree, the sum is 90 degree. 30 degree is complementing for 60 degree. You can think of a glass filled with 30% of the capacity. We can say 30% filled, or we can say 70% empty. They are complementing each other. Similarly, 30 degree is complementing 60 degree. When we add these two, the sum will be 90 degrees. Are these two angles complementary? No. 35 degree is not complementing 65 degree because sum of these two is not equal to 90 degree. Whenever two angles are complementary, each angle is said to be complement of the other angle. 30 degree is complement of 60 degree. In complementary angles. Supplementary angles. We can notice that these two angles, the sum of these two angles is equal to 180 degree. Now let us consider example 2. In the example 2, we can see sum of these two measure of angles is equal to 180 degree. So this is also an example of supplementary angles, because they two supplement each other to form a straight line. Adjacent angles. When you open a book, it looks like this. We find a pair of angles placed next to each other. We can see angle P is placed next to angle A. Both are side by side. We can also look at the steering wheel of a car. At the center of the wheel, we can find three angles lying next to each other. These are called adjacent angles. In example, first we can notice that vertex A and B, we find a pair of angles are placed next to each other. These angles such that they have a common vertex and they have a common arm and they have non-common arms on either side of the common arm. You can see these are non-common arms. Such pairs of angles are called adjacent angles. They have a common vertex, common arm, but no common interior points. Linear pair. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. In this example, we can see there is a common side and we have two non-common rays. This is an example of linear pair because they are opposite to one another. One is going in this direction, other is going in the other direction, in the opposite direction. Is this an example of linear pair? No, because the non-common sides are not in the opposite direction. In simple terms, both non-common sides should make a straight line. The angles in linear pairs are supplementary. You can notice the measure of angle 1 and measure of angle 2 is equal to 180 degree. If it is 180 degree, then it is called a linear pair. Angle 1 plus measure of angle 2 is equal to 180 degree. In our day-to-day life, we see linear pairs in a vegetable chopping board. Here we can see there is a knife and a wooden slab. Wooden slab is forming a linear pair. This forms one angle and the rest of the knife forms other angle, and one non-common side is going in one direction for this angle, and in the second angle we can see the non-common side is going in the other direction opposite to the first non-common side. Vertically opposite angles. Look at the four angles formed in this example. Take two pencils and tie them with the help of a rubber band at the middle. Basically, these two lines are forming four angles. Angle 1, angle 2, angle 3, angle 4. You can notice angle 1 is vertically opposite to angle 3. And angle 2 is vertically opposite to angle 4. We say angle 1 and angle 3 is a pair of vertically opposite angles. Similarly, for angle 2 and angle 4, angle 2 and angle 4 are vertically opposite angles. When two lines intersect, the two vertically opposite angles so formed are equal. But how do we prove this statement? Now let us prove this statement with a simple geometric idea. Let L and M be two lines which intersect at O, making angles 1, 2, 3, 4. We want to prove that measure of angle 1 is equal to measure of angle 3 and measure of angle 2 is equal to measure of angle 4. Now we know that angle 1 plus angle 2 is equal to 180 degree. Subtract measure of angle 2 on both sides of the equation. We will get angle 1 is equal to 180 minus measure of angle 2. Similarly, measure of angle 2 plus measure of angle 3 is equal to 180 degree. Subtract measure of angle 2 on both sides of the equation. We will get this. You can notice that LHS of these two equations are same. So we conclude that RHS of these two equations must be equal. So measure of angle 1 is equal to measure of angle 3. These two are same. The measure of these two angles are same. That is what we need to prove. We proved it. Similarly, we can write for measure of angle 2 and measure of angle 4. The content of this recording is borrowed from Karnataka Textbook Society, Bangalore, under Fair Usage Policy. This video is presented by Avvari Technologies. Please do hit subscribe button to get more content. Thank you.